Here we have the Go control software, which you just saw controlling the Bascule bridge. And it comprises a main program here, and the main program is made up of 4 sub-programs, or as we call them, procedures. Now, one of the nice things about this Go software, it works like a flowchart, using flowchart symbols. So we can write a program in a modular way, in a structured way. And this is very important for programming because, and for teaching children programming in particular, because it teaches them programming and getting their actions and sequence of functions down in an organized and structured manner. It also makes it easier to troubleshoot and to debug the program to make sure that that element or that part of it is working. So basically, if we look at the main diagram here, the working screen, we start the bridge, it asks us to switch on. Yes, as soon as the switch is on, it has a warning light and buzzer procedure. Then it waits 2 seconds. It's the procedure to open the bascules, wait for 4 seconds, and if I scroll down here, procedure then to close the bascules, wait 2.5 seconds, procedure for the green light and buzzer to let pedestrians and motor traffic know that it's safe to cross the bridge, and finally stop. I'll just put a little wait in there so the green light and buzzer would show. Now, the 4 elements that make up this rather complex program, I mean, it looks simplistic here, but in essence each of these procedures is quite a complex little bit of programming in itself, hence the need to teach programming in a structured manner. So I've laid out the procedures here. Here's the 4 procedures that are used in the software, and as you can see, each one in itself is quite a complex little piece of programming. And that's one of the good points about this Go software, is it allows you to see the procedures you're using. It allows you to open one like this one here, to check through it in single step mode, so you can step through it and see if it's working. Probably one of the nice things about being able to program something like this in a modular way is that you could have your class or groups of students in 4 separate groups, each responsible for one of the procedures and ensuring that it works before you put them together. Under the main program, that's this one here, which controls the bridge, and they can work collaboratively on that. One of the other features about the software is that in order to do that you don't necessarily need 4 models, because if we connect what Data Harvest call the ACE, and I'm just going to pick it up now, this is the connects ACEs and Bascule bridges here. Here's our Bascule bridge ACE, or simulation if you like, and I should be able to run this like that, and it shows the students on the screen how everything is working. The model should work. For example, I'll show you one of the programs which is included. If I open, this one has been. So here's one of the example programs which helps students with this. If I start this one, you can see how it's a simple program just to open one of the bascules. So what a lovely feature to be able to see it on screen. They can work independently or in groups without the model itself, so it's not dependent, the software is not dependent on the model being there. But of course, having the model, I think, is vitally important, because as I said earlier, it's the kinesthetic part, the reality part of this. And after all, we hope that programming isn't just a computer exercise, that it has some basis in reality, in the real world that the children live in. So, thoroughly recommend the software. The control boxes works faultlessly. With or without the computer, it can run the program. What a lovely idea for open evenings. You could have your Bascule bridge model, for example, could be any of the other models in the set. That could be running in the foyer as the parents come in for their open evening meeting with the teacher, and says, press a button and watch what Year 5 have done with their control technology.